Welcome, this is Sicong Liu. I usually go by the nickname Zone. I'm presenting the research. Developing expert gaze pattern in laparoscopic surgery requires more than behavioral training, and this work was recently published. Laparoscopic surgery brings many benefits to patients, such as experience a minimal level of intrusive operation procedures and accelerated recovery. However, it poses challenges for surgeons, in that surgeons cannot visually check the body tissues they're working on, but rely on 2D images captured by the laparoscope shown in picture A. In addition, laparoscopic surgeons will experience the fulcrum effect, referring to the fact that the tips of the surgical tools move in the opposite direction of the tool handles with little tactile feedback. This fulcrum effect can be seen in picture B and C, where surgical trainees practice in a simulation task named PAC transfer task. Surgical trainees also have very limited hours devoted to simulation training. Therefore, there are motivations to improve the training program efficiency. Involving eye tracking in surgical training programs seems a promising approach to enhance surgical training programs. Past research has shown that expert surgeons demonstrated more feed-forward sampling strategy than non-experts, in that they look more at objects of future surgical steps rather than surgical tools. However, the evidence is mostly coming from short, single-handed surgical simulations. Given the motivation to improve surgical training programs and the evidentiary limitations, we attempted to answer two questions in this study. Question 1 is about whether the conclusion from past eye tracking studies can be transferred to more dynamical than manual simulation tasks like the PAC transfer task. In this task, the trainee is required to use two Maryland dissectors in the procedure of moving 6 plastic objects in turn from the left to the right side of the flat pegboard, and later reversing the entire process to move the objects back to the left side. Question 2 concerns whether expert gaze behavior can be spontaneously developed given sufficient behavioral training, so that we can understand whether eye tracking in surgical training programs is necessary or not. We recruited 3 surgeons and 5 novices and focused on the PAC transfer task because it has established validity and a behavioral scoring system that considers both speed and accuracy. In addition, as picture B illustrates, we labeled the objects and their goal locations so that we can predict the action sequence in one's task performance. For eye tracking, we use a mobile eye tracker, as illustrated in picture A, and rely on the eye metric of percentage dwell duration because it helps normalize one's overall performance duration, while being able to suggest one's visual distribution on different AOIs. We defined 3 AOIs in that 2 of them are suggesting forward sampling strategy and 1 is suggesting online sampling strategy. The procedures involve having surgeons for 1 visit of testing and having novices for 5 visits of both training and testing. The analysis helps test whether novices have reached their behavioral plateau using an inverse function from previous research, and then test between expert-novice differences on both behavioral performance and gaze behaviors. This figure illustrates the inverse function model used to understand each novice's performance growth throughout the training. The pink vertical line corresponds to the moment of reaching 90% of learning plateau during the training, suggesting that all the novices experience sufficient behavioral training at the end. Here are results comparing surgeons to novices. The figure's left-hand side shows that after training, novices no longer show differences to surgeons regarding their behavioral performance, whereas the right-hand side displays persistent difference between novices and surgeons regarding their gaze behavior. That is, after reaching equivalent level of behavioral performance, novices still show less feed-forward sampling than surgeons in gaze behavior, implying less flexibility in their attention distribution during performance. Overall, the present study extends previous research to more realistic surgical tasks. More importantly, the findings suggested that future surgical training programs should consider eye tracking because merely offering behavioral training to novices cannot help them develop expert-like attention style.